Symmetric relations. So a relation is symmetric if A is related to B implies B is related to A for all of the elements A and B in the set that R is a relation on. So I'm going to look at the examples we looked at when we defined relations. So if you haven't watched that video, you should do that now. So R on the positive integers defined by R equals 1, 1, 1, 3, 2, 2, and 7, 10. We want to know if this is symmetric. And the answer here, of course, is absolutely not. Because in order for a relation to be symmetric, you should be able to change the order of any ordered pair in it and get another ordered pair that's in it. And here we have the ordered pair 1, 3 is in there, but 3, 1 is not. And same with 7, 10 is in it, and 10, 7 is not. So that would be your justification. 1, 3 is in the relation, while 3, 1 is not in the relation, or 7, 10, and 10, 7. So that one is not symmetric. The next one was the parents one. So A is a set of all people. A is related to B if A and B have at least one common parent. Symmetric. So if you have an ordered pair in that relation, the first person in the ordered pair has at least one parent in common with the second person in the ordered pair, so the second person in the ordered pair has to have at least one person in common, at least one parent in common with the first person in the ordered pair. So this is definitely symmetric. Next example was the relation R defined on the integers by R equals the set containing ordered pairs A, B, so that the second element in the ordered pair is an integer multiple of the first element. Symmetric. And I think we talked about this when I did the definition of relation. The answer here is no. Why? Well, because, say, like 5, 10 is in the relation, because 10 is equal to 5 times 2, but the ordered pair 10, 5 is not in the relation, because 5 is equal to 1/2 times 10, so 5 is a multiple of that first element, but 1/2 is not in the integers, so this is not symmetric. Next was a relation on the reals defined by A was related to B if A is less than B. Symmetric. So if we had an ordered pair A, B in there, that would mean that A was less than B. Can you turn that around? If A is less than B, is B less than A? Absolutely not. So that is not symmetric. And you can give a specific example, like 1, 3 is in the relation, while 3, 1 is not in the relation. Okay, and there was one more example. Yes, the set. Let me just do sort of shorthand. Define R on the set of finite subsets of Z by A is related to B if the number of elements in A is equal to the number of elements in B. Symmetric. Absolutely. Because if the set A has the same number of elements as the set B, then the set B has to have the same number of elements in the set A. So I think that one's fairly obviously symmetric. So there you have it, 5 examples, some symmetric, some not. The next property we'll look at is transitivity. Okay, very good.